All right, at the base of the Mobile Bay. And of course, we can look across the bay. And remember, all those high spots that you see, that's that tough, durable rock that we were talking about, right? That layer, right, that's eroding really slowly. So you can see those high ridges over there, right? That's where the rock comes up. And then it dips right back down underneath the bay here, right? And if this bridge wasn't here, we'd be able to see that it crops back up. So it acts like this really tough, durable basement, right, as I was talking about. So let me ask you guys a question here, right? If I wanted to look at the bay itself and figure out how the bay works and what kind of rocks are deposited in the bay, what could I do to study what's going on underneath the water here? There's two ways that I could look. Right, that's under the water. What do we call those? When I get a sample, they're usually round. Physical students, you learned about it in the seafloor chapter.
Oh, come on, people. You're killing me.
What do we call it when I drop a pipe that goes down? And it gets pushed down, and then there's a trap on the bottom that gets set, and I pull it back up, and I can open up the pipe and see the sediment. What do we call that?
Something throwing something.
What do we call the middlemost segment of our Earth? The core, yeah. Oh, we can take a core sample, right. So we can take a core sample, right? So that's actually getting a sample. And of course we like core samples because it takes a section of the rock in place, right? It's not just not dredging, right? Everything's in place where it would be. So if I was going to take some core samples across here, would I just take them randomly all over the place? You think? That I would make a transect, so I would make a straight line, right, and go all the way across and take my samples of my rock. And then what I could actually do after that is what we call correlation, right? I could be able to see, well, I've got a sand over here in this sample and a sand over here in this sample, right? And basically be able to flesh out the whole model of the layers that are underneath here. Now, there's also another method I could use if I have a lot of money to spend, so if I work in oil, and I got a lot of money to spend on research, there's another way I can collect information without taking any samples out of the ground. What's that? No, but it begins with an S.
Sonic?
Not quite sonic. Seismic. Right. I could take seismic imaging. Remember, seismic is just the vibrations, right? So when we hear the word seismic, we usually think of earthquakes, right? That's where we get most of our seismic. Of course, we can generate seismic, right? Which, of course, being in New Orleans, you've all experienced that. You're in your house, a nice big truck drives down the road, everything in your house shakes. That's seismic, right? So, of course, as we're walking, we generate seismic. Well, I can generate seismic out here as well. What it's called is a seismic boom. It's essentially like the end of a giant wrecking ball. And they send it down and they pound it into the ground, right? And it sends out those vibrations. And, of course, those vibrations are going to come back to recording devices. And every rock has a different kind of vibration that records as it goes through it. Limestone is going to look like this squiggly line, and shale is going to look like this squiggly line. And if you get really good at reading squiggly lines, right, you can start to paint a picture of what's going on. Does anybody here have their packets with them? Good. Oh, yay, good. There's, if you open up your packet, there's a page in there that's got the squiggly lines. See, I think it's, yeah, that picture right there. So if you take a look, okay, at that page, okay, this is what seismic information looks like. Now that seismic's been labeled for you, right, because I know most of you guys don't know how to read squiggly lines. But if you take a look, okay, at that paper, you'll see, right, we've got the base of the river, okay, down there. And then what's the, can you all see where those lines start to look horizontal? What's written right on top of that? Right at the bottom. What does it say? What are the words there? I know you can read, you're in college.
Maximum flooding surface, distributary.
Right. What's the low?
The lowest.
The lowest. Because remember, we start on the bottom.
Uniform.
Right. Low stand unconformity. Remember, right? As our material's deposited, right? The oldest is on the bottom, youngest is on the top. What principle is that? Holy crap! I'm asking you to think on a Saturday. What principle is that?
Come on, physical. We just did this.
Begins with an S. 5 syllables? Sounds
I'll have a
like
test on Tuesday.
superposition, right? Oldest on the bottom, youngest on the top, okay? So as we start to look at this seismic story, we start on the bottom. So we can see down there, we've got all those nice flat layers, right? And then it says low stand unconformity. What is it, unconformity?
Okay, we haven't gotten
You guys
there
should
yet.
know this. Historical students, at least, you should know this. What's an unconformity? Haley's in
Not the same.
historical.
Something that's not.
You don't remember what an unconformity represents? No. An unconformity represents a period of time that I'm missing in my rock segments, right? So if I'm looking at this whole segment of rock, I'm missing some time. What process could occur that would help me or that would erase time? Geologically, what was that? Erosion. So an unconformity generally represents a period of erosion, non-deposition and erosion. Now, why is it important to mention that? Well, A, it gives us a concept of time, right? We're missing time. But also, as a geologist, right, we get very well versed at reading these rocks like a book, right? If you were to sit down with a book and if I were to rip 20 pages out of the middle of it, would it be easy to read? No, you don't know what the hell's going on, right? Same thing with the rocks, right? I've got to recognize where I'm missing geologic time. So let's think about what that means, that low stand unconformity. So we've got deposition that occurred, right, to make those nice flat rocks that you see. And then I had an unconformity. So I had erosion occur. So let me ask you this. If I've got erosion occurring, does that mean that those rocks were exposed to the air or were they deep underwater? They were exposed to the air. So what does that tell us about sea level? It had dropped, right? So that means at one point in time, you could walk straight across this bay. So in periods of low sea level, you could just walk straight across here. That's how we produce. There's a couple of unconformities that you can see on there. So what that's showing us is those changes in sea level that we talked about before, right? Sea level gets really high like it is right now. We're depositing all sorts of sediment, right? All that sediment's traveling down the bay, right? Coming through the Bay Head Delta. Moving on through here, little bits getting deposited in through here, but for the most part it's getting trucked out, right, to the Gulf of Mexico. Sea level starts to drop. As sea level starts to drop, that Bay Head Delta that y'all drove through is going to move, right? It's going to move more seaward, right? So as it moves, we'll think about how much deposition's occurring. That was okay, we're on soft stuff, but that's relatively solid, right up there. Well, if sea level drops, it's going to become more relatively solid out here. But now it's exposed to the air, so every time it rains or all that stuff, it's going to start getting eroded, producing that unconformity. Now, of course, if you look on top of that low stand unconformity, there's more rocks on top, right? So that means at one point in time we have more deposition. So what does that tell you about sea level? It rose, right? Sea level came in and covered up all that material, allowing for more deposition to occur. Now, what happens in the Bay Head itself is actually pretty cool, okay? So what will happen is in periods of low sea level, we get all this deposition. Like I said, you can walk straight across it. And then when sea level rises, okay, or even in periods where if you get really heavy snow up north, right, and things start to melt, right, there's going to be more runoff. But what's going to happen is you get more runoff, sea level rises, these rivers become more active. Like I said, it acts like a giant toilet bowl. It flushes anything that's loose out into the Gulf of Mexico. So all this bay does is it fills up with sediment, gets flushed out. Fills up with sediment, gets flushed out. And it's been doing this for thousands of years. Isn't that kind of cool? You can lie and tell me it's cool. I won't know the difference if you're lying or not. It's pretty neat stuff. All right, now if you flip the page, you can actually see, and I'm not going to go through it, but you can actually see all the diagrammed phases of this, right? And you'll see the dotted line on there that shows you sea level and the fluctuations of sea level and how it's risen and fallen through time, right? So how this area is filled up and been flushed out. Now, just projecting ahead with where we're going to go, do you think that's important to Dauphin Island out there? Definitely. Yes. Dauphin Island is built around all the sediments that are coming through this system. When we get out to Dauphin Island, you're going to see, right, all these ridges of resistant rock. It's going to outcrop again out there. We're going to have a hill out there. And that's where all the sediment that's moving through the system that gets flushed out, it's getting stuck around that hill. And that's what's making the island. Now, if you look at the base of the bay out here, you've got Dauphin Island, and then you've got mainland of Alabama right there. It's a very narrow channel, which of course is very important for shipping, right? Because there's a lot of ships that come through here. Okay, but do you ever think that that would close off? Maybe.
They got enough sediment.
Yeah, enough sediment. Yeah, maybe. Think about it. It's like acting like a channel, right? So essentially, we've got all this water moving through here, and it's going to channel through that really small area. So what happens, right? If this is my channel, you're going to get a lot of sediment getting deposited right in here. It's going to cut through that channel real quick, and the sediment's going to splay out in different directions, right? So some of the sediment's going to move this way to the west, right? Some of it's going to move to the east, and it's going to get stuck around Dauphin Island, right? And of course, these barrier islands are incredibly important, okay? Because what do they do for us?
Protect us.
How do they protect us?
By stopping the water from breaking it up or whatever from coming through.
Exactly.
Right.
Slows down storm surge, right? So it helps break up wave energy, right? So these are incredibly important. So what we're going to look at after lunch, right, is when we get out to Dauphin Island, we're going to see how can we make these islands healthy? How are they staying, right? Because that stuff is constantly eroded all the time. So how the heck is there an island out there to begin with, right? So we're going to take a look at the natural processes that occur, okay, to be able to figure that out. We feeling good about this?
Processes out there too.
Yeah, these are all, well, we have a couple, but you're going to see that they're failed processes. Yay, Army Corps. I'm going to rip on the Army Corps of Engineers for a little bit, so I apologize. If any of y'all work for the Army Corps, have family that work for the Army Corps, I'm going to rip on them for a few minutes when we get out there. You're going to see a waste of about $200 million. It's going to be awesome. So, any other questions? Do we feel pretty good about, you got a question?
Yeah.
You got a question? Just wait for the birds. Gotcha.
Oh, they
Do we feel good about this system? Is it making sense? I know you're just going to let me ramble, right, if I want to ramble. But is this making sense so far?
Yeah.
Okay, good. All right, so what we're going to do, oh, Susan, you got a question?
Hard rock, you said, goes down underneath. What is that?
It's a limestone.
That's limestone.
Right. Now, of course, it is eroding.
You said
But it's eroding very slow. Any rock that's exposed to water is going to erode. Even this concrete's eroding. Okay. And of course, that's not real rock. Hopefully, you know that. Right? But, right, it's eroding really, really slowly. So, you're gonna see some, you're not gonna see any limestone, but we're gonna see some other rocks. Real rocks. Right? You can't see those in New Orleans.
I've been waiting all semester to see.
Right?
I take online.
All right, so what we're going to do is we're going to take an hour for lunch. It's noon, so I want to meet back up. We parked kind of over by the submarine that's out there, so why don't you meet up with us about 1 o'clock. You've got a couple options for lunch. You can go to this brick building over here. If you love greasy truck stop food, that's the place to go. If it makes you sick, like it makes me, I brought my lunch. But there's a couple of restaurants right around here. Even there's a little motel over here. They've got a restaurant in there. If you go off of Battleship Park, wait for us to come out. Pull into that hotel parking lot. Don't pay to come back in. Just wait over there and you're going to see us all funnel back out. Okay? But we're going to leave at 1. So if you go on the ship, I am not waiting for you. I am leaving at 1 o'clock. We got lots of stuff to go do on the island.